Let's get started. Let's understand what is engineering, why we need it, and where we need to start with. This is Sai Fanindra from SQL School. I assure you complete cautious learning process. Need your support. Number 1, on-time practice. Number 2, no mobile logins, desktop logins required. Number 3, number 1, on-time practice. Number 2, no mobile logins, desktop logins or laptop logins required. Number 3, you get the complete notes in advance, take print copies and get ready for the classes. Number 4, weekly submission of assignments. Only then we can enjoy the beauty of this course. Bit vast. I want serious, cautious learning participants. In this lengthy item data engineering, we have ETL to start with. What is this? Extract, transform, load. And here we'll be learning certain tools and technique, open source as well as Microsoft, both. ETL techniques we need to learn in our data engineering course. Number 2, data warehouse, again open source and Microsoft, both technologies, data warehouse technologies we need to learn in our classes, and more importantly, how to gel them, how to integrate them together in a single end-to-end pipeline we call, or end-to-end project. In this process comes big data concepts and analytics concepts. Both are different and we need to merge them again, called big data analytics. Different technologies for each of these 4 items. And we have data factory, Microsoft ETL. What is that? Data factory we call Azure Data Factory. That is Microsoft ETL. Then we have something called, I said something because I assume we are all very new to our subject. Let's learn together. In our classes, we have something called Databricks, open source ETL. Gelling together, we have Synapse. It has the beauty of both data factory and Databricks, Synapse engineering, part of our classes. And the backbone for all these items, data lake. From data lake came something called Delta Lake, One Lake, Lake House, the derivatives. Truly speaking, it's a chemistry class, really. Hence my diagram. It's like a chemistry, lot of integrations, lot of formulations. We need to think an extra mile in every aspect. And here, these are all about ETL concepts. Then what about data warehouse? We have open source Spark. Spark is an open source data warehouse. Spark databases we are going to create. We have something called Python for ETL, PySpark, Scala, and other entities as well. Let's understand slowly why we need all these items. Let's understand slowly, step by step. To get into this engineering, firstly, let's have a short glance at database. A platform to store any type of data, any amount of data, fully secured. And there are 3 basic types of databases. For any project in real world, we usually see teams working with different types of databases for end-to-end integrations. OLTP databases, SQL developers will take care. OLTP, the live online transaction processing database system design. Data warehouse databases, you and me, data engineers need to take care. OLAP databases are taken care by BI developers and architects. Online analytical processing databases. Our course is into number 2, data warehouse. Now, here it is. To make it more clear, OLTP, online transaction processing databases. These databases store live real-time data like live temperature, live stock market, anything live, like a live cricket match. Developers will take care. Data warehouse, data engineers will take care. They store old historical data as well as aggregated data. From there comes a small diagram on my screen. OLTP, firstly let me put this way, OLTP left. Okay, OLTP left. From OLTP comes, okay, from OLTP comes the next item, ETL, extract, transform and load. ETL we call it. So OLTP left side, live online transaction processing databases. From there comes something called ETL, that valet parking service, ETL concepts. From ETL comes data warehouse. Assume an online banking environment. Assume an online banking environment. Savings accounts, current account, loan accounts, your PAN, TAN, SSN, Aadhaar, whatever we say, file system. Everything can be integrated using ETL. Clean the data, shape the data, filter the data, get only required, selected, cautious data, meaningful data, and load it to the warehouse. Warehouse is our godown. Different showrooms, the transport system, and the godown. Now, this warehouse can be implemented in different ways. And there we are. Let's slowly understand now. Number 1, ETL, extract, transform, load. There are different technologies in the market to implement ETL. Here it is, Databricks, open source, databricks.com, open source, and Snowpark, open source. Snowflake plus PySpark is equal to Snowpark, open source. And PySpark, again, open source. To implement PySpark, we need some platform like Databricks, in fact. And we have branded ETL items as well, like Azure Data Factory, ADF we call, Microsoft ETL, and Synapse Analytics, and something called Fabric Data Factory, Microsoft Fabric. These are all ETL technologies. If anyone planning for Fabric, remember Microsoft Fabric has something called Data Factory. That Fabric Data Factory, here it is, Fabric Data Factory and Azure Data Factory concepts are bit similar. This is FDF we call, Fabric Data Factory. What about other companies like Amazon? We have Amazon Glue. These are all ETL technologies. Our course is into Databricks and PySpark, Data Factory, and Synapse Analytics. Our Azure Engineering course. If you are into Snowflake Engineering, our separate course planned for about 4 weeks, there you have Snowpark. Fabric Data Factory course or Fabric, Microsoft Fabric course, 2 months course now, bit vast. Fabric is very vast now, 2 months. There we have this item separately. Our Azure Engineering, our actual intro class is about open source ETL, Microsoft ETL. Then towards the right side comes warehouse. Databricks loves Spark databases. In our classes, in our Azure Engineering, part of our course will be taking good number of examples on working with Spark databases. We have something called Spark notebooks, Spark queries, understanding about creating Spark Hive Metastore and Spark databases, understanding the differences between regular SQL database and Spark databases. And we need to learn how to work with Spark activities, creation of tables, and more importantly, something called parameters, jobs, widgets, etc., etc., with end-to-end integrations practically. Remember, it's all about Spark, open source warehouse. Databricks and PySpark together love Spark databases. And what about Data Factory and Synapse? Together loves something called SQL Pool. There are 3 types of pools we have in SQL. This is Microsoft Warehouse. What about Amazon? Amazon has Redshift. Snowpark has something called Snowflake. Snowflake is a warehouse. Its ETL is Snowpark. Spark database is a warehouse. Its ETL is Databricks and PySpark. Combined together, can be implemented separately. And Amazon Glue ETL, Redshift warehouse. Our course is into 3 kinds of pools and 1 Spark database. To make it clear, this is our actual concept. We are into ETL, open source ETL, Microsoft ETL, open source warehouse, Microsoft warehouse, and very importantly, end-to-end integrations. This involves ADF plus Databricks plus one of them called Synapse Analytics and Synapse SQL Pool plus Power BI reporting. For this, the input will be IoT, Internet of Things. And this is your project for the course. Reference line. From here, end-to-end implementation from databricks.com. It's a public website. And there you see part 1 data engineering, part 2 machine learning actually. Okay. Data engineering is a backend. Machine learning will be the next level applicative tier actually. Data Factory plus Databricks plus Synapse. Open source ETL, Microsoft ETL, and this is again open source warehouse. We say bronze, silver, gold, and Microsoft warehouse. They go together. Remember, open source ETL, Microsoft ETL, open source warehouse, Microsoft Warehouse, they go together. That is our actual course. And where to start with? Please make sure you have knowledge of MS SQL. We need it. As a data engineer, yes, we are into, once again, to make it clear, Microsoft ETL, open source ETL, Microsoft Warehouse, open source warehouse, and bridging layer in between with end-to-end integrations. Now, to enjoy the things in an easier way, we need to have SQL prerequisite. Microsoft SQL, regular ANSI SQL, Oracle SQL, or MySQL may not really work for our examples. Let me put it straight. Please understand my concern. I want to do my best. And I'm fine with it. Please understand my concern. Attendees from Oracle or MySQL or Sybase or SnowSQL or Google BigQuery or SAP SQL, anything, or Excel SQL, any SQL, please spend some time. Revise MS SQL concepts during your free time for a happy, easier implementation of engineering. For example, let's make it straight. Today, a few hours back, where is my email here? Yes, I'll put my email, okay, this one. Today, few hours back, just I think 2 hours back, we did one data engineering class for 1 hour back, actually, 7 p.m. ongoing batch. We did security. It's all MS SQL only. These are all MS SQL queries. We need it part of data engineering. And then we did something called incremental load, multi-table incremental loads. There again, we have something called data factory activity step by step, MS SQL queries, Microsoft SQL queries, something like this. Yes, remember, we no need to be a programmer here, not required. But MS SQL concepts are required, especially normal forms. Joins group by anywhere it is common, no problem. But normal form implementations are required for us. We are going to involve in warehouse design. Normal forms are required for us. Views, procedure, function, triggers, basics are enough for me. Architecture, please revise it. As you know, the architecture is the basement for any technology, right? Please get it. That is more important for us. Add on for experience profiles, last line, experience profiles, cursor, CTE, merge, rank, Excel imports, temporary tables, variables and parameters. If possible, revise them during your free time. Any questions during your revision, I am there. Mark my words. But make sure we do it carefully, cautiously, without any compromise. In our engineering classes from tomorrow, we'll start with fundamentals for first 5 minutes. Then we need to have something called server, database, and warehouse creations. Start the practice. This is the only PPT slide for the entire course. Trust me, this is the only PPT slide for the entire course. And from tomorrow, we need to slowly start our practice one by one. This entire 7 weeks journey, total 8 weeks actually, 7-week classes and 1 week for your project. Entire 7 to 8 weeks journey divided into 3 different departments, 3 different modules. Microsoft ETL and warehouse module, 3 weeks. Open source ETL and warehouse module, 2 weeks. And 2 more weeks, the common friend. For staging, polybase, integrations, and something called as key vaults, templates, encryptions, etc. Data lake, delta lake, and one lake, lake house concepts. At the end comes implementation, integration activities. With this information, now over to you for questions, clarifications. This is the project work. Your interviewer may ask us, your interviewer may ask you, first question, usually first question, what are the challenges in your project? Explain your project, right? Usually, right? Explain your project. What are the challenges in your project? What ETL techniques you used? How to optimize ADF? How to optimize Databricks? How to optimize SQL Pool, etc., etc., so on. So we need to go there. Let's learn from the scratch carefully, step by step. Once again, let me repeat. Point number 1, on-time practice. Number 2, no mobile logins, please. It won't work for our class because we are complete into practice zone. It's an introduction class. I should be very clear and straight. Desktop or laptop login only. Mobile logins, small screen, it won't work. Please understand my concern. I should be straight and frank. Number 3, take print copies of the notes. You'll be getting the complete notes in advance, module wise. 3 modules I said, right? 3 departments. This is Databricks and PySpark module notes. Every notes is only 2 to 3 pages. I respect your time. We're investing our valuable time in addition to your ongoing job. I respect your time. We'll go straight to the point. Only one notes is, I think, about some 10 pages. Okay, for weekend reading and other activities anyway. But remaining all, again straight to the concept. Okay, what is what? Complete synopsis. Complete document, at the end synopsis. We'll do one by one. Something like this to make it clear. In this way. The complete synopsis of the document. That's how it would be. I think, yeah, 8 pages. Remaining all 2 to 3 pages straight for each example, one by one. What is what, where to right click, where to left click, etc. This is one module notes out of 3 modules. Same way, other module notes. Storage, one by one, step by step activities as it is. And every practice notes in the class will have task items. You have the practice followed by synopsis and tasks. So if we practice on time, then this course is for us. Weekends we have assignments. I need your support. Things are a bit vast. Planned for serious, cautious learners. Please understand, it's a demo class, so I should be cautious. I want serious learners so that we can have happy classes here. With this information, over to you, and any questions, please let me know. Glad to assist you. Over to you now, and after Q&A, time permits, we'll start our configurations today. If not, we'll have a fresh start tomorrow, starting from the Azure configurations to continue further. We'll stop for now.